Four-stroke cycle. The vast majority of certified aircraft reciprocating engines operate on the four-stroke cycle, sometimes called the Otto cycle after its originator, a German physicist. The four-stroke cycle engine has many advantages for use in aircraft. One advantage is that it lends itself readily to high performance through supercharging. In this type of engine, 4 strokes are required to complete the required series of events or operating cycle of each cylinder. 2 complete revolutions of the crankshaft, 720 degrees, are required for the 4 strokes. Thus, each cylinder in an engine of this type fires once in every 2 revolutions of the crankshaft. In the following discussion of the 4-stroke cycle engine operation, note that the timing of the ignition and the valve events vary considerably in different engines. Many factors influence the timing of a specific engine, and it is most important that the engine manufacturer's recommendations in this respect be followed in maintenance and overhaul. The timing of the valve and ignition events is always specified in degrees of crankshaft travel. It should be remembered that a certain amount of crankshaft travel is required to open a valve fully. Therefore, the specified timing represents the start of opening rather than the full open position of the valve. During the intake stroke, the piston is pulled downward in the cylinder by the rotation of the crankshaft. This reduces the pressure in the cylinder and causes air under atmospheric pressure to flow through the carburetor, which meters the correct amount of fuel. The fuel-air mixture passes through the intake pipes and intake valves into the cylinders. The quantity or weight of the fuel-air charge depends upon the degree of throttle opening. The intake valve is opened considerably before the piston reaches TDC on the exhaust stroke, in order to induce a greater quantity of the fuel-air charge into the cylinder and thus increase the horsepower. The distance the valve may be opened before TDC, however, is limited by several factors, such as the possibility that hot gases remaining in the cylinder from the previous cycle may flash back into the intake pipe and the induction system. In all high-power aircraft engines, both the intake and the exhaust valves are off the valve seats at TDC at the start of the intake stroke. As mentioned above, the intake valve opens before TDC on the exhaust stroke, valve lid, and the closing of the exhaust valve is delayed considerably after the piston has passed TDC and has started the intake stroke, valve lag. This timing is called valve overlap and is designed to aid in cooling the cylinder internally by circulating the cool incoming fuel-air mixture to increase the amount of the fuel-air mixture induced into the cylinder and to aid in scavenging the byproducts of combustion from the cylinder. The intake valve is timed to close about 50 degrees to 75 degrees past BDC on the compression stroke, depending upon the specific engine, to allow the momentum of the incoming gases to charge the cylinder more completely. Because of the comparatively large volume of the cylinder above the piston, when the piston is near BDC, the slight upward travel of the piston during this time does not have a great effect on the incoming flow of gases. This late timing can be carried too far, because the gases may be forced back through the intake valve and defeat the purpose of the late closing. After the intake valve is closed, the continued upward travel of the piston compresses the fuel-air mixture to obtain the desired burning and expansion characteristics. The charge is fired by means of an electric spark as the piston approaches TDC. The time of ignition varies from 20 degrees to 35 degrees before TDC, depending upon the requirements of the specific engine to ensure complete combustion of the charge by the time the piston is slightly past the TDC position. Many factors affect ignition timing, and the engine manufacturer has expended considerable time in research and testing to determine the best setting. All engines incorporate devices for adjusting the ignition timing, and it is most important that the ignition system be timed according to the engine manufacturer's recommendations. As the piston moves through the TDC position at the end of the compression stroke and starts down on the power stroke, it is pushed downward by the rapid expansion of the burning gases within the cylinder head with a force that can be greater than 15 tons, 30,000 psi, at maximum power output of the engine. The temperature of these burning gases may be between 3,000 degrees and 4,000 degrees Fahrenheit. As the piston is forced downward during the power stroke by the pressure of the burning gases exerted upon it, the downward movement of the connecting rod is changed to rotary movement by the crankshaft. Then, the rotary movement is transmitted to the propeller shaft to drive the propeller. As the burning gases are expanded, the temperature drops to within safe limits before the exhaust gases flow out through the exhaust port. The timing of the exhaust valve opening is determined by, among other considerations, the desirability of using as much of the expansive force as possible and of scavenging the cylinder as completely and rapidly as possible. The valve is opened considerably before BDC on the power stroke, on some engines at 50 degrees and 75 degrees before BDC, while there is still some pressure in the cylinder. This timing is used so that the pressure can force the gases out of the exhaust port as soon as possible. This process frees the cylinder of waste heat after the desired expansion has been obtained and avoids overheating the cylinder and the piston. Thorough scavenging is very important because any exhaust products remaining in the cylinder dilute the incoming fuel air charge at the start of the next cycle. As the piston travels through BDC at the completion of the power stroke and starts upward on the exhaust stroke, it begins to push the burned exhaust gases out the exhaust port. The speed of the exhaust gases leaving the cylinder creates a low pressure in the cylinder. This low or reduced pressure speeds the flow of the fresh fuel air charge into the cylinder as the intake valve is beginning to open. The intake valve opening is timed to occur at 8 degrees to 55 degrees before TDC on the exhaust stroke on various engines.